Hello students, in this recording I will share the introductory part corresponding to wireless LAN, where we will discuss the introduction. Under the introductory part we will discuss the architecture difference, the architectural comparison in between wireless LAN and the wired LAN, and then certain characteristics. And many of the characteristics already we have discussed, because majority of the characteristics we have discussed while discussing uh, our earlier while taking up the earlier lectures corresponding to attenuation, interference, these kind of characteristics. Anyways, corresponding to the wireless LAN, once again we will revisit all these things. And then later on, I think in the next recording, I will record corresponding to IEEE 802.11 project. And there mainly we will discuss CSMACA, the access control mechanism which being used in wireless LAN for collision avoidance. CSMACD, that is being used in case of wired Ethernet, whereas when it comes to wireless LAN, we rely on CSMACA, because you know it very well, because earlier also we have discussed that why CSMA-CD is not applicable in wireless scenario. Already we have discussed a lot about that. That's why there are fine-tuned MAC medium access technique, particularly for wireless environment. So here one of the technique, one of the wireless medium access control technique, that is CSMA-CA, for collision avoidance. In detail we will understand that thing, and that's it. And so let's start with the introductory part. Under the introductory part, you all know that why wireless is in demand, so I will not discuss a lot about this. You know the reasoning behind it, you know the reason, and why do we require specific protocol corresponding to wireless LAN instead of directly using what we are using in case of wired environment. So here we will see the architectural comparison. So we will straightway start with the architectural comparison in between wireless and wired LAN. So first is on the ground of medium. So as you know that in case of wired and wireless, as the name specify, even the naming convention is based on the medium. It is wireless medium and the wired medium. But in case of the wired medium, initially the medium, even in case of Ethernet, if you will see, the medium was broadcast. Even the bus topology was being used in the earlier Ethernet. So even there, if you notice, the medium was broadcast, whereas over a period of time, in case of the wired Ethernet, it being changed from broadcast medium to point medium. So to handle point to point medium is way easier on the ground of medium access. Whereas if you will see in the wireless environment, obviously the environment is wireless, that is the broadcast medium. So you require specific, some fine-tuned protocol to avoid collision, because here we can't rely on collision detection, because that is not possible at all. Detection is not possible at all in case of the wireless medium. So we have to instead rely on collision avoidance. So on the very first instance itself, the protocol is to be fine-tuned on those parameters, on those scales, so as to avoid the collision at the very first instance itself. So that is one thing. So that is regarding the medium. Then we come to the host. So when we discuss about the host, so here we will discuss in terms of the mobility environment, in terms of the mobility of host. In case of the wired environment, mobility is not that much. It is not so that your node can't be mobile. So suppose if you are a part of one LAN and you want to move your host from one LAN to another LAN, you can do so easily. You can do so. Your link layer address, that is your MAC address, is going to be same. Obviously, when you will move from one location to another location, you will be assigned different IP address. But when you are communicating, when you are active in operation, in communication, at that time, rarely you will move from one location to another location. So prior to your communication, you have to configure uh, your device so as to be compatible with that environment, that is with that LAN. So you have to acquire the address, your LAN address, that means your MAC address is going to remain same. Whereas in case of wireless medium, wireless LAN, you are more mobile. And even when you are moving at that time as well, you are communicating. So it is not so that prior to your communication, your configuration, so on the go itself, when you are moving, at that time, sometime the requirement comes to configure and to take new IP address and all. So these type of requirement comes too often in case of wireless LAN. Then we come to the isolated LAN. So you can see when there is an architectural difference. So obviously how we will deal with in terms of the protocol, if you will see, obviously the protocols will differ. And on which layers we have to work when we have to deal with LAN, on link layer and physical layer. So this network interface card, and means its design involve physical layer as well as the data link layer. So the overall impact of these architectural comparison, architectural difference would be only on these two layers. So if you are moving from your wired environment, so in case of the moving environment, moving between environment, so if you are moving from your wired environment to wireless environment, obviously the protocol design will differ based on the architectural difference and based on different other characteristical differences. So the impact would be only on these two layers. So obviously your network interface card, you have to change your network interface card. So in that situation, your link layer will change. So obviously if you are moving from wired environment, there is one NIC, network interface card, which is supporting the Ethernet interface, which is supporting the Ethernet LAN. If you are moving from that Ethernet LAN to the wireless LAN, obviously you have to change the network interface card. So once you will change the network interface card, your link address is going to be changed. Your MAC address will differ then. But obviously, if you are the part of the same network, because above your link layer, network layer, till the application layer, these layers are not going to be changed. So your IP address is going to be same, provided you are the part of the same network, same LAN. You're just changing the environment. You're changing your environment from wire to wireless. So under that circumstances, you have to change your interface card. Now instead of wired interface, you require wireless interface. So you require new NIC card, network interface card, that holds different link address. And so your IP address, if you are the part of the same LAN, will remain same. Now isolated LAN, we will see. So here we will see in terms of the difference, we will see the isolated LANs, wired versus wireless. So in case of the wired architecture, we know the switches operate on link layer. So all the devices which are directly connected to the switches are the part of same LAN. And what is good about switches is that one host can communicate with all other hosts via switch. So switch would facilitate that thing. Prior to switch, it was hub. Switches are smarter hubs, you can say, which knows when you want to communicate with this host. So from here, if you want to start as a source and here you want to come as a destination, so over a period of time, switch will learn these paths. So if this host want to communicate with this host, so switch knows on which interface it has to relay the packet, it has to relay the frame. Whereas with hub, the problem is that hub works on the bit level. So whatever the bit comes to the hub, it would relay it on all the other interfaces except the one on which it's being encountered. Whereas in case of the wireless network, the concept is same. So overall theme of the LAN will remain same. But the problem is that here there is no concept of switch at all. So all the devices can communicate with each other. So all the devices are in a way self-configured. They doesn't require anything because the medium is wireless. So the medium is broadcast. So if anyone is broadcasting, every other one is listening to it. Whereas the same operation is being governed by hub or switch in case of the wired environment. Because the LAN concept is that whenever you are communicating, every other one should listen it. But the switches are way smarter that if you want only this host to listen, so switch would allow you to do so. Whereas in case of the hub, you will see, so hub will allow every other one to listen. So the same thing goes along with the wireless environment, but without any facilitator, without any device which would facilitate this, because here medium is facilitating all these things, because here the medium is wired medium, that is point to point. So to facilitate that, you require an add-on device, and the add-on device is switch in the case of wired environment, or hub. Prior to switches, hubs were there, which facilitate this kind of a theme, this kind of a requirement which our LAN should fulfill. Whereas here, the medium is facilitating that requirement. So we doesn't require the switches and these kind of things. That is the difference. Then the next difference is connection to the other network. So suppose in case of the wired environment, you are the part of one wired LAN and you want to communicate with the outside world to other environments. So you require an access router, which would allow you to connect and contact the outside world. So here also we'll see it with an example. So here you can see, so suppose if you are the part of this wired environment, wired LAN, switch is facilitating that LAN concept. Now, in order to contact the outside world, you require an access router, which would facilitate your communication with the wired internet or whatever the internet it is there, which is outside to you. Whereas in case of the infrastructure network, not infrastructure means in case of the wired environment, why we are saying the infrastructure network. So in the wired environment, when you require an access point to facilitate the contact or the communication of these hosts to the outside environment. So this is an infrastructure. So you have to install, you have to deploy an infrastructure to facilitate this kind of communication, but never get yourself confused this access point with switch. Switch facilitate the LAN environment. Switch is to facilitate the LAN theme, which I have given to you. What is the LAN theme? That if anyone would start communicating its packet or relaying the packet, others should be able to listen to it easily, which being facilitated by the switches. Whereas what access point is doing here, we have deployed access point uh, for facilitating its contact to this environment contact with the outside world. And this access point would act as a glue. So it would act as a glue in between the wired and wireless environment and the outside wired environment. So this access point is directly connected to the access router, because without router you will not be able to facilitate the outside communication. So you require a communication. So to access this router, you require this access point. So that's why the name given to this device is access point. And what access point would do, access point would glue your environment, which is wireless, to the wired environment. So you require an access point to glue the wireless environment with the wired environment. So never get confused yourself with the switch. Switch is switch is to facilitate the LAN environment, whereas the device itself and the medium is the facilitator of that LAN theme. Whereas this access point is to contact this access router and in a way to contact the access means outside world. So for that purpose, we require the access point. And all these problems, that corresponding to the wireless environment, we have these kind of problems: hidden station problem, exposed terminal problem. So once again, I will not repeat about these things. So these also comes into the characteristics, because B wants to communicate with A, C wants to communicate with A. This is what their range. So this ellipse is showing the range of B. This one is showing the range of C. So A can communicate with both B and C, but the problem is, so C is hidden to B and B is hidden to C. So in that situation, if both B and C would start at the same time, there would be a collision at A. So there is no point of communication. So you require to handle this kind of problem. So in your MAC and in your MAC protocol, while accessing the medium, because the medium is broadcast, to access the medium, or to facilitate the communication, you require to somehow handle this situation, handle this problem. And the same problem can happen not only because you're not under the range, there may be something which will block your range. So this is physical interference, which is blocking the C. Though in that range issue, if you will see, B and C are within the range, but problem is happening due to this physical blockage. That's why B and C are hidden from each other. Now in the next lecture, I will discuss the specific project 802.11 project. And there mainly I will discuss about the MAC sublayer. And particularly under the MAC sublayer, I will discuss about this protocol CSMA-CA, collision avoidance. It's an interesting protocol. How to avoid the collision. Whereas in case of the wired environment, we relied on detecting the collision. The moment you detect the collision, then you refrain from sending, then you retract and once again restart it. That is a collision detection protocol. Here we will focus on CSMA, CA, and at the physical layer you have different technologies. So one by one we will see that what just the name itself reveals that what we are using in terms of the modulation and all at the physical layer. So 802.11 frequency hopping split spectrum we are using, 802.2 A, B, G, all these things. So we will see at the physical layer, but the focus would be more on this distributed coordination function DCF. Here at this layer we will use CSMA-CA. There is a protocol at the point coordination function as well. We will see the importance of that, but primarily our focus would be on this layer. This is the distribution. This is the division of the data link layer. In the next lecture, we will see in detail.